So again, good morning, student. So today we have a very important topic that with the standard, and this topic is just equivalent to weightage. If we can say that, ki like as a modern physics of class 12 in the point of JEE and NEET perspective, the KTG we can say ki thermodynamics, kinetic theory of gases and heat transfer, complete thermal science at least 8 to 10 marks. We can say that in each and every topic we can expect at least 2 questions from every segment. So, and that is very easy topics. So we can say that this is very scoring topic. Here we can produce good marks with less effort. Okay, that's why we are going to start our thermal section. So before going to start our thermal section, we have to develop our thought process how heat transfer, kinetic theory of gases and thermodynamics, what are the basic pillar of our thermal science. So as name suggests that thermal, so we have to think about what is heat and temperature. What is heat and temperature? We have some basic idea about heat and temperature. Then we can start the topic. So heat and temperature, basically, if talking about, so heat means we can say that is the form of energy in transit state. In the transit state, the form of energy due to temperature difference. And whenever the heat flow because of the temperature difference, the simple formula came into our mind that delta Q equal to ms delta T. ms delta T. So what I want to say, beta, is the whole chapters depend upon some basic thing, and the things is heat and temperature. So firstly, we have to understand the meaning of heat. Heat is basically two types. One is the because of the temperature difference, and another is because of the phase change. So whenever between system and surrounding temperature change is involved, we have to write down the heat in this manner. Whenever phase change is occur, suppose some material get converted solid to liquid or liquid to gas. So here phase change is involved. So in this case, we have to write down the heat in the mass into latent heat. Latent heat of that state. Either solid will get converted into liquid, then we have to use latent heat of fusion. When liquid will get converted into vapor, then we have to use latent heat of vaporization. I hope this is clear to how we can use two formula of heat, and there is only two formula. I am not going to discuss there are 4 to 5 formula, only two formula of heat. One is due to temperature difference and another is due to phase change. Okay, and what is the basic thought process about the temperature? That is the vibrations of molecules because of their kinetic energy. We can say because of their thermal agitations, the vibrations of molecules, the energy possessed by molecules is regarding, we can say, refer to temperature. Okay, so let's start our topic. I hope everybody should join the session, and this session is really helpful for you because again I want to tell you that this topic is very important. And why this is important? Because here he can produce very good score in less effort. That's why we can say we must try at this topic, and before JEE main exam, we have to try to note down all the important points, whatever I am going to discuss in today's class. Okay. Beyond the class, I think there is no single question will come into JEE main that you can't solve. If you listen each and every point very carefully, you will able to solve each and every problem of the JEE main. So what your task? after the completion of class, you must try the previous year JEE main paper from 2018 to 2022. All the set of JEE main paper from 2018 to 2022 you had to solve. Okay, all the important concept and formulas that I am going to discuss in class, and there is no need to note down during the class, because all the notes and recording lecture will provide in your WhatsApp group. So there is no need to worry, sir, we have to note down all the things. Okay. During the class, you have to listen and consciously and focus on the concept, whatever I am going to discuss. Okay. So let's start. First of all, I am going to cover the kinetic theory of gas section. Basically, what is the kinetic theory of gas section describe, beta? The kinetic theory of gas section just discuss about the behavior of the molecules. So we can say here we study the microscopic behavior. Microscopic behavior of gaseous molecules. Okay. What is the meaning of the beta micro and macro? In macro, we discuss about the average behavior of the system, but in the microscopic, we just interested to average, not average, that individual behavior of the molecules. So this is also known as the microscopic behavior, and here the system is gas and the gas is ideal. So firstly, we have to understand the meaning of ideal gas. What happened most of the time, what is the recent trends of the JEE main, there are some theoretical concept is also involved. So they can easily ask some property of ideal gas. So we have to also study what is the properties of ideal gas. The size of gas molecules is negligible as compared to size of container where gas is filled. The collision occurs between the gas to gas molecules and gas to container wall is perfectly elastic. So we can say there is no loss of energy because of the perfectly elastic collision. Potential energy is zero. So we can't consider the interatomic potential energy, the potential energy due to interaction of the molecules. The motion is the Brownian type of motion, that is the random motion of gas molecules. The instant contact, we can say the contact time is very, very less. No effect of gravity. It means for the given container, if gas is filled, the density is constant. That is the meaning of the no effect of gravity. So we can say density is constant in a whole the container chamber. And this is the game-changing formula for the kinetic theory of gas. And this formula of ideal gas, we can always apply that PV equal to nRT. Here we have to understand the meaning of the P, that is the pressure of the gas, volume of gas that filled in any container or system, number of mole of gas, and R is the universal gas constant. What is the R? Universal gas constant. Universal gas constant, and T is the temperature. Sir, what happened in thermal section? Most of the time, because of the exam pressure and some adverse situation, the temperature, we can't give much focus on temperature. Temperature is always put in Kelvin. We have to remember this thing. First of all, whatever temperature is given, we have to convert it in Kelvin. Then we have to put in this equation. Okay, let's move for the next slide. Here, we are discuss about the what is the state of the gas. State of the gas means that is the some property, some characteristics of the gas, some coordinate of the gas. If I say this is the some particular point, we can say gas is present at this point. Then what is the coordinate of gas? Here I am not interested at x, y, z coordinate. Here I am to find out the property coordinate. What is the pressure, volume, temperature of the gas? So we can say we can identify the state with the help of the property. If property remains same, if all the property remains same, we can say state is not going to be changed. If any one property in given three property is changed, we can say state of gas is going to be changed. So we can say this is the pressure, volume, temperature at initial state. So we can say this is the state 1 and this is the state 2. When we want to change the state of gas, we must involve some process. By means some process, the state of gas can be changed. So there are multiple types of processes possible. We discuss in later slide. Okay. So first of all, when a closed container is given, so one thing is very much clear: the total number of moles of gas is not going to be changed, irrespective of any process involved here. Okay, something like this process is isothermal. Suppose this process is isochoric, isobaric. The number of moles of gas present in the first state must be equal to number of moles of gas in the second stage. So we can say number of moles, we can say in this equation P1 V1 upon T1 equal to P2 V2 upon T2. So which type of question is asked by using this formula? There are 6 parameters and only one parameter the examiner can ask you. Suppose that what is the final temperature at state 2 and all the property coordinates are given. Then we have to use this formula. I hope this is clear, and this is very useful for your gaseous state in chemistry also. So we can say that the topic kinetic theory of gases that touch chemistry and physics, both this is also very important for us. Okay, let's move for the next. What happened? Suppose this is a container 1, this is a container 2, and initially we put a cork here. So we can say the movement of gas from this section to this section is not allowed. If we remove the cork, then what will happen? Here we are consider one assumption that the system is isolated. So we can say there is no heat transfer from surrounding to system or system to surrounding. So what we can say that the total internal energy of the complete system is always conserved. So we can say initial internal energy of the system, when they allow to mix, that will equal to total internal energy of system. And the second one, that total number of moles is also conserved. So here we can say the first property, number of moles is conserved here. And in the previous slide, we learned how we can write down the number of moles in terms of pressure, volume, and temperature. And suppose that if this whole the process occur at constant temperature, so we can say that it is mixing occur at constant temperature. When gas mix in the given volume, then total volume will become V1 plus V2. Then what is the final temperature of the mixture of the gas? It is asked. How we can find out? We can say T0 at if this mixing is occur at constant temperature. So we can easily find out the final pressure, that P1 V1 plus P2 V2 and divide over V1 plus V2. Again, this is very important formula, beta. Why very important? Because there are multiple types of questions are found here. Okay, when the mixing is allowed and temperature is constant and the vessel is isolated from the surrounding, then we can use this formula for finding out the final pressure of the mixture. Okay, let's move for the next. I hope everything is clear in this slide. Okay, what is the ideal gas equation? As we saw previous slide, that PV equal to nRT. This gaseous equation takes multiple forms, and we have to basic understanding how we can write down the ideal gas equation in multiple forms. Is PV equal to nRT? Most of the time this equation is applied for the closed container. So we can also say this is the container form ideal gas equation. And we know from our basic chemistry that number of mole is always written that mass of the gas divide over the molecular weight, that is the molar mass. Okay, beta. So we can say here mass upon volume is known as density. So this can be again another form of the ideal gas equation, P equal to rho RT upon molar mass or molecular weight. This can be used when we move upward to our sea level. We can see different layers of atmosphere. Suppose stratosphere, troposphere. Then what is the variation of the pressure? Such type of question you ask. And this formula we can also use when density is given in the problem. Suppose ideal gas is kept at particular density and we have to find out what is the pressure of the gas. Then we can use this formula. This can be also used when container is open. I hope this is clear. Okay, Vana. Okay, Vana. I hope this is clear. I want to reduce my speed. Okay. P equal to rho RT upon M, because this formula is used for open atmosphere. We can say that this formula is also valid when container is open. Okay. Next, we have to use, sir, if I have 1 mole of gas, then we can say that in 1 mole of gas, how many molecules are present? So you can say that is equal to Avogadro number. That is equal to Avogadro number. I hope this is clear. If I have n mole of molecules, then what is the number of molecules? N into Avogadro number. That is the total molecules of gas, and say that the total molecules is n. If total molecules is n, then n is always written equal to number of moles into Avogadro number. Here we can replace small n, that number of molecules of gas divided over Avogadro number. If we put this formula in this equation, what will happen? See here, PV equal to, in place of number of mole, we can put beta the number of molecules of gas in container divided over Avogadro number into RT. Here R upon Avogadro number is known as Boltzmann constant. We have to remember this thing. R upon Avogadro number is known as Boltzmann constant, and that is represented by letter K. That is represented by letter K. K is known as Boltzmann constant. I hope this is clear for everyone. This equation, that is another third form of equation, PV equal to NKT. When this formula we have to apply it, beta, when directly number of molecules of gas is given, then we can use PV equal to NKT. I hope this is clear. Should I explain it again? Should I explain it again? If you have any query, you can test in chat box. Okay, let's move for the next section. There are 3 forms of the ideal gas equation. PV equal to nRT. This is used for the closed container and when number of moles is given. PV equal to rho RT upon molecular weight. When we have to apply this formula, when the density of gas is given, when we move in atmospheric, in upward direction of the sea level, we can say air is also treated like as an ideal gas. So we can also use this formula for the atmospheric condition when we move upward. I hope this is clear. And the third equation, when the numbers of molecules are involved, then we have to use PV equal to NKT, where K is Boltzmann constant. Okay, beta. Let's move for the next. This is the Maxwell distribution curve. Actually, what is the importance of this curve, beta? This curve describes about the velocity of the molecules, which type of velocity of molecules, and how many molecules carry this, which type of velocity. Actually, this is the probability distribution curve. We can say that where y-axis we consider the relative number of molecules, and x-axis we consider the speed or velocity. Okay, molecular speed, that is basically 3 types of speed we have to learn. One is the most probable speed. What is the meaning of this, beta? Most probable speed means there are how many number of molecules which contains x type of velocity. Okay, so we have to count the number of molecules. Suppose in a class of 100 students, there are 70 students who likes physics. So we can say that is the most probable subject. Okay, beta. So this is the meaning of the most probable velocity, and that is written under root 2 RT upon M. What is the keen observation here beta कि sir any type of velocity irrespective of most probable, mean, this can be also said that ki average and RMS in all the formula of the velocities that is proportional to under root temperature, that is proportional to under root temperature. So that is very important observation here. Sir, velocity, any type of velocity that is proportional to under root temperature and that is also inversely proportional to under root molar mass or molecular weight. I hope this is clear for everyone. Yes, yeah, no? And sometimes we have to also remember this formula. What is this value? What is this value? That is the 1.41. 1.41. What is the this value, beta? What is the this value? This value will equal to 1.59. 1.59. What is this value? 1.73. So what we observe here, beta, which velocity is having, which speed having greater magnitude, we can say कि RMS, then average, then most probable. Yes or no? We mean we can say V average. So what is the correct sequence of their speed? So we can say that there is the factor 1.73, here 1.59, here 1.41. So if there is a question asked, what is the increasing order or decreasing order of RMS speed, average speed and most probable speed? So we can say VRMS is always greater than beta that V average, and V average is greater than V most probable. We can say that this is important observation here. And we can also remember by a trick RAM. So we can say R means root mean square, A means average, and M means most probable. I hope this is clear. Yes or no? And we much interested in RMS velocity just like as a alternating current circle, that this signifies the initial behavior of the gas like pressure, volume, and momentum. Pressure, momentum, energy that described by the RMS velocity. It means we more interested to find out the RMS velocity. Okay, beta. So this is the basic meaning of the Maxwell distribution curve, and this is the peak of Maxwell distribution curve that defined that this velocity having more number of molecules. So we can say that this velocity, this particular velocity having greater number of molecules, and this is the number of molecules here we can say that, and this velocity is the most probable. I hope this is clear. Let's move for the next section, beta. That again, this is the important formula. What is the pressure exerted by gas? What is the pressure, beta? If we describe the basic meaning of the pressure, so we can say gaseous molecules, that is random motion occur in the gaseous molecules where there is no interatomic force. So they collide each other, they collide container. When they collide to container, they exert a momentum change. There is a momentum change occur. And we can say that when suppose we consider a molecules here, that is the three-dimensional molecules. When the molecules, we can say here a 3D space we consider, and we consider a molecules. When a molecules consider the wall, it must possess a change in momentum. So we can say firstly, change in momentum come into picture, and we know from Newton's second law, whenever change in momentum, there is a force will come. So this is applied to force. We interested here because there are a lot of number of molecules. We have to find out the average force. And we know that if we know the force and divide over area, we will get pressure. This is the thought process how gaseous molecules exert pressure. Firstly, momentum change occur, then the average force come into picture, because we know that the average force is nothing but a rate change of momentum. And we know that beta average force divide over area, that is the pressure. So this is the thought process how pressure come into picture. I am not interested in the derivation part because we have to proper understanding of formula. So just move for the formula, beta. What is the formula, beta? So sir, what is the formula here? That pressure exerted by gas molecules because of the collision with the container wall, that is 1/3 density We have to see here rho is the density and V RMS square. Sir, why V RMS square? As we see in previous slide, we much interested in RMS velocity because it describes the inertial behavior, that is the pressure, momentum, and energy. And this is the very important formula again. Whatever formula I put in box, you can understand that is the very important formula. By remembering this formula, you can solve multiple 100 times of problems, beta. Okay, sir, how? P equal to 1 by 3 rho V RMS square. Again, apply the ideal gas equation that PV equal to nRT. Okay, sir, here density is come. So we have to write down the ideal gas equation in the form of density. There is any equation that we can write down in form of density? Yes, sir. That P equal to, see here, beta, P equal to rho RT upon molar mass. I hope this is clear. If we replace beta P, if we put the value of P in equation number 1, what we see that root rho RT upon M, this can be written as 1 by 3 rho V R MS square. Rho and rho is cancel out, and we can say V RMS, that can be written as 3 RT upon M. 3 RT upon M. There is a very fabulous question that can be asked. What will happen? What will happen if we increase the pressure of the gas in the RMS velocity? We can't comment beta, because in this form pressure and density both are present. If vary the pressure, density will also vary. So what is the safer side? We have to convert in the form of temperature. Okay, and from this equation it is clear that the RMS velocity depend upon the temperature and the molecular weight of the gas, that is the molar mass of the gas. I hope this is clear for everyone. Let's move for the next section. Because gas molecules are continuously in motion, so we can say that they must possess some translational kinetic energy, and by rotation, by virtue of rotation, rotational kinetic energy. If the gas is put a very high temperature, the vibrational kinetic energy is also involved in picture. So we have to keep in mind. And the important law that we have to discuss here, law of equipartition of energy. So law of equipartition of energy, what is the basic meaning of law of equipartition of energy? Each gas molecules that possess energy, that half kT, this is the equipartition of energy corresponding to each degree of freedom. The energy of gaseous molecules is half kT. What is the degree of freedom? Degree of freedom means the molecules possess energy in each and every dimension. How many dimensions molecules possess energy? That tells about the degree of freedom. If we talk about in translation motion, so we can say X, Y, Z. There are 3 possible directions we can define. We can say the translational degree of freedom is 3, rotational degree of freedom is 2. And we can say that for the non-linear molecules, that rotational degree of freedom is 3. So we have to also keep in mind, if I am talking about monoatomic gas, that monoatomic, something like helium, neon, argon type of gas, this type of gas only 3 degree of freedom is occur, because the dimension of molecule is too much small. So we neglect the moment of inertia of molecules. We don't consider the rotational degree of freedom. Monoatomic 3. For diatomic, we can say degree of freedom is 5, and the polyatomic, for the polyatomic, in the case of polyatomic, there are 2 cases. One is the linear, something like a CO2 type of molecules. We can say here degree of freedom is again 5. But non-linear molecules is possess 6 degree of freedom. 3 plus 3, 6. And whenever in the question it is asked about high temperature, then we have to consider the vibrational degree of freedom. And the vibrational degree of freedom in each mode contribute to. We can say we can increase our degree of freedom by factor of 2 if it is say in the problem that we have to put the gas at very high temperature. Okay, beta. So here we can say that equipartition energy, that is the energy of one molecules. If molecules having F degree of freedom. So this formula will become F by 2 kT. I hope this is clear. This is for 1 degree of freedom. So this is for F degree of freedom. And suppose get if I have beta n number of molecules. If I have n number of molecules, then what is this formula? So we can say this formula will become that nk. Yeah, we can say suppose we have 1 mole of gas. Then what is the formula? For 1 mole of gas, we can say that this formula will become F by 2 number of 1 mole, that is the Avogadro number, into kT. And we can say this term is known as the universal gas constant. For 1 mole of gas, this formula will become F by 2 RT. And suppose in general, if we are interested to find out what is the degree of freedom in n mole of gas, we can say this is the formula n F by 2 RT. And F by 2 RT. So this is again very important formula, that number of molecules of gas is given and number of moles is directly given in the problem. Then we can say that internal energy of gas molecules is F by 2 nRT. This is the formula valid for n mole of gas. And here we can say that this is the degree of freedom, this is the number of mole, and this is the universal gas constant to U is directly proportional to temperature. So this formula is also very play important role in thermodynamics, where we have to interested to find out the internal energy of gas. Okay, beta. So it is a question. Internal energy of gas is a function of pressure, is a function of volume, or is a function of temperature. So we can say here this is very obvious. Internal energy directly proportional to temperature. If we increase the temperature, internal energy of gas increases. If we decrease the temperature, internal energy of gas decreases. Okay, beta. And this notes, whatever I prepare for you, that is really helpful for you. So firstly, we have to read all the PDF very carefully after the class. It's my humble request to all of you. We have to read carefully, because there is no single question that is asked in JEE Main that beyond this slide. Okay, so you have to read every theoretical point very carefully. So here if we want to find out what is the change of internal energy, so we can say we can write down in the function of temperature that n r delta T. Okay, beta, I hope this is clear. What is the important crunch point here? That change in internal energy is written as degree of freedom by 2 into nr delta T, where F is the degree of freedom. Suppose if you want to write down the change in internal energy for monoatomic gas, we can say degree of freedom for monoatomic gas is 3 by 2. Suppose if gas having number of mole is n r delta T. In similar manner, we can write down the equation for a given nature of the gas. Again, we want to find out what is the degree of freedom of the mixture or equivalent. Suppose I have gas 1, where number of moles of gas 1 is the N1 degree of freedom of, suppose, different type of gas, monoatomic, diatomic. So say this is the having degree of freedom F1, gas 2 having degree of freedom F2, and number of moles is N2, and so on. Suppose there are n types of gas are present and we want to mix them, we want to find out the mixture, that degree of freedom of the mixture. One thing again we have to consider here, suppose this is the 1, this is the 2, this is the 3. Want to allow the mixing of that, we consider that this is again an isolated system. So we can say there is no heat transfer from system to surrounding is occur, and vice versa. So here heat transfer is 0. So we can say whatever exchange occur, that exchange occur internally. So total internal energy change, we can say the total internal energy change of the molecular level is equal to total molecular internal energy change of the system. So by using that concept, the equivalent degree of freedom that can be written as beta N1 F1 plus N2 F2 plus and so on. If suppose in mixture only 2 gases are present, we can say we can extend till this and divide over total number of moles, sum of total number of moles. I hope this is clear. This type of question directly asked. If you see the previous year question, that 2018 to 2022, because of the multiple sets, so we can see that such type of question is generally asked. Okay. Let's move for the mixing of gas at different temperature. In the previous slide, the same temperature that will occur. Here, at different temperature that will occur. So we can say that U mixture, this U means internal energy. This can be written as U1 plus U2 plus U3 and so on. And how you can write, sir? U can be right. We know that, sir, this can be written as we know N1 F1 by 2 RT1 N2 F2 by 2 that RT2. In same manner, we can proceed for the derivation part, but we can't interested in derivation at too much time is very small here. So we can say that how we can remember this formula that N1 T1 F1. Yes, sir, N1 T1 F1. Yeah, N2 T2 F2 and so on. And divide over here, we can write down the internal energy for the mixture that F1 N1 plus F2 M2 plus and so on. So here, if we mix the gas having different number of degree of freedom, then what is the equivalent temperature of the mixture we can find out the mixture temperature by using this formula. I hope this is clear for everyone. Note down, and that is very important point, beta. Suppose which type of question is asked. Suppose in a container that is hydrogen gas is present, and here suppose that helium gas is present. Say helium gas is present. We can say this is the diatomic, this is the monoatomic. So what is the F1 here? That is the 3. What is the F2 here? That is the 5. Say the initial temperature of helium is 300 Kelvin and the hydrogen is, we can say 400 Kelvin. Okay. And the number of mole of helium, that is the 2 mole and that is the 4 mole. Then we have to find out if we allow the mixing in the adiabatic container, in an adiabatic ball, then what is the temperature of the mixture? What is the temperature of the mixture? Then we have to use this formula. I hope this gives a clarity which type of question and what is the application of this formula. Okay, guys, so let's move for the next slide. Again, next slide. The similar thing that we discussed in the previous slide, if we remove the cork, the exchange of gas will occur and we can find out the final temperature. And if you want to find out the mixture temperature, then what we have to do? We have only two separate tools. One is the conservation of internal energy and another is the conservation of mole. We can say initial mole of both the gas equal to final mole. Okay, beta. By using this formula, we can find out the final pressure. We can find out the final pressure, and it's my belief, beta. If you try the problem, you just solve each and every problem because these are the some concluded part past over 10 to 15 years. 10 to 15 years, which type of questions are generally asked? So that concept I will attach in this slide. Okay. Let's move for the last topic of the KTG beta. That what is the mean free path? What is the mean free path? Suppose one molecule, we consider a hypothetical cylinder having 1 meter length, and if we process a molecule, if we allow a molecule to go inside the cylinder, and the molecule goes into cylinder, and the dimension of that cylinder we consider that 2D. Okay. So here the mean free path, that distance between two successive collision. What is the meaning of successive collision? Suppose that the first collision occur, then molecules cover some distance, and then second collision occur. So after the first collision, what is the distance covered by molecules in that interval? That is known as the mean free path. We know that the gaseous molecule in Brownian motion, in random motion, they collide to each other. So here sometime it is asked mean free path parameter, how it depends. So this is written as 1 upon n pi d square. What is the small d beta? Small d is the diameter of the molecules. Here n is the number of molecules per unit volume. Again we have to remember n. What is the n beta? Number of molecules per unit volume. Okay beta. So we can say that which type of question is generally asked, because it is given, suppose one molecule having this diameter, another having this diameter, then find the ratio of mean free path. Okay, so here we can say that our mean free path, that is inversely proportional to number of molecules per unit volume, and that is inversely proportional to 1 upon d square. And sometimes beta, one important term, that is the relaxation time. Relaxation time is the simple time that we can say that mean free path divided over the velocity, that is the average velocity. Here we can say that if we know the behavior of mean free path with n and d, we can also comment over the relaxation time. One more thing, beta, sometimes pressure and temperature is also involved, and then we have to find out the relaxation time. How we can write down this? See here, sir, we can say that the lambda that can be written as here, if you want to write down that lambda is proportional to 1 upon n and d square. Okay, we only write down the proportionality constant, we can remove here because pi is no important here, and this is the velocity. Okay, if we put the value of lambda here, then tau expression will like this. Okay, okay, sir, it is clear. Sir, one thing more, we know the ideal gas equation, PV equal to nRT. Yes, this is the PV equal to nRT. What is the equation in the form of molecules? PV equal to nKT. Okay, sir, what is the n upon V here? If we find n upon V here, this is known as the number of molecules per unit volume, and that is the small n here. So we can say small n here also replaced by P upon Kt. P upon Kt. So in the place of small n, we can put P upon Kt. So this will become Kt upon P d square upon V. See here, beta, that is the very important concept, that tau, how tau is vary with temperature. And here is the average velocity. And average velocity, any type of velocity that is proportional to under root temperature. So we can say that this tau is proportional to T upon P. If we remove the diameter, if you consider a diameter of molecule is constant, then velocity is also proportional to under root temperature. So here, what is the proportionality constant of relaxation time? That relaxation time is proportional to under root temperature upon pressure. In the previous recent 2 years, such type of question is asked, how relaxation time is vary with temperature, that under root of temperature divide over pressure. I hope this is clear for everyone. Okay, beta, how we can correlate the relaxation time with temperature, you can understand the whole process. What is the meaning of the thermal equilibrium? Actually, let's start the thermodynamics. In the thermodynamics, we discuss about basic 3 law. One is the zeroth law, and the first law of thermodynamics, and the last one is the second law of the thermodynamics. Okay, so zeroth law talk about the thermal equilibrium, that give the concept of the temperature scale. If somebody asks to you what is the outcome of zeroth law, one answer you can give, that is the temperature scale. Because of the zeroth law, we are able to measure the temperature, that is the temperature scale. What is the outcome of the first law? You can say that it's our internal energy. Okay, beta. And what is the outcome of second law? That is the entropy. That is the entropy. Okay, beta. That is the some basic important points about the thermodynamics. And thermal equilibrium means temperature must be equal to, temperature of system must be equal to temperature of surrounding. If we mixing two gas, the temperature of one substance equal to temperature of two substance. Okay, because temperature is the driving force to flow the heat. Here again, as we already discussed about the property, how property can be changed. In the first law, basically we interested, suppose if we have a container and we put some gas here, and if we supply some heat from the lower portion, then what will happen, beta? This heat must be increase the internal energy of the gaseous molecules. And suppose that if we put a piston over here, and after increasing the internal energy of gas molecules, they hit the piston. If they hit the piston, they want to raise the piston. It means we can say they want to perform some work. Suppose that key by cylinder we can supply 100 joule of energy, 100 joule of energy in the form of heat, and it absorbs some energy in the form of internal energy, say 60 joule energy it absorbs. Then what is the work performed by gas? You can say total heat supplied by the cylinder, that is the 100 joule, 60 joule that increase the internal energy of gas, the remaining 40 joule that is the work performed by the gas. This is the basic mathematical form of the first law of thermodynamics. Heat supplied, heat exchange must be equal to given into two parts, internal energy change plus work done by the gas. Okay. One more thing we have to keep in mind, beta, in physics, in thermodynamics, whenever heat supplied to the system, whenever heat supplied to the system, it taken always positive. It increase the internal energy of the gas. Whenever heat rejected from the system, it consider negative. It consider must be a negative sign. Whenever work done by gas, it means gas is independent, beta. Yes or no? Gas can do work. That is the good thing for gas. We can say work done by gas always taken positive. If we work on gas, we can say work done on the gas, that taken negative. So by using this consideration, we put the sign of heat work with above consideration. Suppose one question, suppose this is a system and we supply a heat that is 20 kilojoule to the system. Okay, listen question carefully. And gas perform a work, that work done by the gas that is given that 10 kilojoule. In the question, it is asked find out the change in internal energy of gas. So anybody can solve. How we can solve change in internal energy of gas? It is given in the problem 20 kilojoule heat supplied to the system and 10 kilojoule work that done by the gas. Okay, beta. Okay. Very good one. We can say, sir, we just put this value in this basic formula, and that is again a game-changing formula for the thermodynamics. The whole thermodynamics is concentrated about this formula. Okay, बेटा. मतलब सर क्या मुझे थर्मोडायनेमिक्स में दो चीजें आती है, मैं कोई भी क्वेश्चन फोड़ दूंगा. बस आप ये फार्मूला याद रखो मेरे लाल, और साथ ही साथ आपको ये याद होना चाहिए कि सर ये सब गैस के लिए अप्लाई होता है, और वो गैस के लिए तो मैं हमेशा ही पीवी इक्वल टू एनआरटी लिखूंगा. आई होप इट इज क्लियर. और वर्क हर एक प्रोसेस का निकालना आना चाहिए. हीट चेंज में वैसे ही लिखना जानता हूं. यू कैन सॉल्व ईच एंड एवरी प्रॉब्लम. खत्म. वी कैन से इफ यू पुट द वैल्यू 20, सर दिस इज वर्क डन बाय गैस प्लस 10, दैट इज डेल्टा यू की वैल्यू हो गई बेटा 10 किलो जूल. At the same time, in the question it is asked, solve this problem also. The gas rejected from, the heat rejected from the gas is the 20 kilojoule, and work done on the gas, this is the on the gas, work done on the gas is the 40 kilojoule. What is the change in internal energy? What is change in internal energy? Work done on the gas is the 40 kilojoule, and the heat rejected from the gas is the 20 kilojoule. Find the what is the change in internal energy. Come on, what is the change in internal energy? Again we apply this formula, and we have to consider. Very good, beta. We can say this is the rejected, so we can say minus 20 equal to delta u, delta w work done on, we can say sir minus 40. So again that is the correct answer, beta. I hope this is make understandable to you. Let's move for the next section. That we already know, sir, in the previous KTG, we know that internal energy is always written NF by 2 R delta T. Okay, sir. Okay. What is the F by 2, beta? That is also known as the F by 2 CV. F by 2 R is known as CV. Okay, because we know that, beta, Mayer's formula, that Cp minus Cv equal to R. That is the Mayer's formula. And Cp upon Cv, that is written as gamma, that is adiabatic index. If we solve this two equation, put the Cp value gamma times Cv, to Cv equal to, here Cv equal to R upon gamma minus 1. It is clear. And Cp, that is gamma times of Cv, that gamma R upon gamma minus 1. Here Cp, Cv we know. And we also know, beta, how gamma is related with degree of freedom. So this is the important formula we have to also know. Yeah, Mayer's relation, Ganesh. We also remember this formula ki gamma is always written that gamma is the adiabatic index CCC 1 plus 2 by F. Okay. Once we know about the F, we can find out the value of gamma. Once we know what is the degree of freedom, we can find out the adiabatic index. We can also correlate different type of equation in the multiple forms. I hope this is useful for you. Okay, beta. And this is the formula of change in internal energy because we replace F by 2R by Cv. This formula is always applicable not only for the isochoric process. Just not see, sir, Cv is here, we can apply only for isochoric process. No, it can be always applied irrespective of any process. Okay, so we have to keep in mind. Let's move. What is the mixture Cv, Cp and gamma? We can apply this concept by using previous analogy. Okay, because we know that N1 C1, N2 C2, N2 C3. This is, I think, understandable for you. By this means we can calculate Cv equivalent, Cp equivalent, and gamma that can be also by written this relation F equal to gamma equal to 1 plus 2 by F. So by transfer the term, we can say F can be written as this. Okay, and in the previous section of the Ktg, we can find out the equivalent of mixture. Okay, where we can put 2 upon gamma minus 1, so we will get this value. So these are the very important formula. Why we discuss? Why we can't discuss directly numerical part? Because these are some theoretical concept that make you strong. Okay, that develops a thought process by means you can solve PYQ questions by own. Okay, beta. Let's do some process study. How many types of process? Sir, what is the meaning of process? To change the state. To change the state. What is the meaning of indicator diagram? That PV diagram is known as the indicator diagram. If volume is constant, isochoric pressure is constant, because we know that unit of pressure is bar, also isobaric, isothermal, and adiabatic. Adiabatic means, beta sir, the two fast process. There is no time for heat transfer. So we can say heat transfer is here 0. Okay, beta. And this is applicable PV equal to nRT. So let's see this chart. Each and every process we have to calculate the work done and heat supplied. You can see here, sir, isochoric process, it means volume constant, and the basic formula of work done in thermodynamics beta, that dW equal to PdV. If volume is constant, we can say work done 0. Okay, and what is the happen in the case of the isothermal process? In the isothermal process, that nRT ln V2 by V1, that is again very important formula. And we can derive the formula. We put PV equal to nRT for the isothermal process, that is the nRT upon V, and we know that dV upon V, if we integrate this will be as ln V, log V. Okay, so we can say once applied, write down the work done in each and every process, then apply the first law of thermodynamics. Then we will get idea about the heat. I hope this is clear. I hope this is clear. We also plot the diagram for each and every process. We can say this is the isochoric, this is the isobaric, isothermal, and adiabatic. What is the difference between the isothermal and the adiabatic beta? PV equal to constant, that is known as the isothermal, and PV raised to power gamma equal to constant, that is the adiabatic. Here gamma, that is always greater than 1. So we can say here more rapidly change in pressure, a small change in volume as compared to isothermal process. We can say this graph is more steeper as compared to this graph. I hope this is clear. Okay, beta. So we have to remember work done for each process and how we can calculate his supplied value. Okay. The left, that is the also important point. What is the relation between the slope of isothermal and adiabatic process? And we know from our basic mathematics, slope of PV diagram is nothing but tan theta dP upon dV. So here it is an important relation. If you are interested in the derivation part, we can also see here that dP upon dV, that slope of adiabatic process is gamma times of slope of isothermal process. I hope this is clear. And this is the important formula beta, PV raised to power n. There nothing is mentioned here, so we can say that is the polytropic process. That is a hypothetical process. That is the hypothetical process, that PV raised to power gamma equal to constant. And suppose a polytropic process, can we say that heat transfer is 0? No, sir. Heat transfer is zero only for the adiabatic process. In general polytropic process, we can't comment. Okay. And suppose in the polytropic process, if n molar of gas is given, then what is the change in heat transfer? We can say n C delta T. What is the C here, beta? What is the C? That is the molar specific heat of the polytropic process. How we can calculate? By this relation. So remember this relation. C Cv upon Cv plus R upon 1 minus 1. Cv plus R upon 1 minus 1. And in previous slide, we know about Cv, that R upon gamma minus 1. So let's see one question on this concept. In a process, if PV raised to power 2, PV power 2 equal to constant, then find the heat required to raise the temperature of gas from 300 Kelvin to 500 Kelvin if n equal to 2 and gas is monoatomic. So how we can solve? Anybody in this class can solve this problem? You can use this identity for the polytropic process. What is the C? Cv plus R upon 1 minus 1. So how we can solve beta? We know that sir, in any process heat transfer can be written as n C delta T. Sir, we don't know about the C. Sir, this is the polytropic process. How we can write down the C? That Cv plus R upon Cv plus R upon 1 minus 1. We can say in previous slide, if any doubt, okay. Sir, what is the Cv? Sir, R upon gamma minus 1, R upon 1 minus 1. Sir, what is the gamma, sir? Sir, monoatomic gas is given. Okay. If monoatomic gas is given, then we can directly write Cv equal to, we know the formula F by 2R. Okay. And this is also written as R upon gamma minus 1. In any form we are comfortable, we can use. What is the monoatomic gas? That degree of freedom 3. This will become 3 by 2R. Okay. So this will become beta 3 by 2R. R upon 1 minus n. In place of n, by similarity, we can put 2. So 3R by 2. And this will become beta minus R. What is the value beta? R by 2. Okay. How many mole? Sir, there are 2 mole of gas is taken. Okay. And C is R by 2. Delta T, that is 200 Kelvin. So we can say that this is required answer. This is required answer. I hope this is clear for everyone, beta. Okay. In adiabatic process, similar we can write down the work done in polytropic process, beta. P1 V1 minus P2 V2 divide over polytropic index. If n here, then n minus 1. I hope this is clear. Okay. This is the again very important concept, that temperature variation in linear process. Suppose that this is an isothermal process. So we can say if let's consider a temperature say 300 Kelvin. So we can say along this line temperature 300, 300, 300, 300, 300. It is asked in problem at which point temperature will maximum. So we can say 300, 300, 300. If we join a line linear approximation here, so what we can conclude here, beta? At this point, straight line temperature is 300. At this point of straight line temperature is 300. Yes or no? Yes, Ganesh, beta. That is very. So what we have to do, beta? After the class, we just read each and every point of slide. Almost 60-page slide that I have prepared for you. You just read each and every point. If you face any doubt, you can test me. Okay, beta? After the class, you have to do, this is your task. And solve all the PYQ question from 2018 to 2022 of the JEE Mains, because there is not too much time. So because of the time constraint, I think 4 years question you can easily solve. Okay. So we can say, sir, here 300 vary. In which point the variation is maximum? Sir, this point variation is maximum because temperature 300, 300, 300 again become 300. Okay. It means at some point it will increase and will get maximum value. Again, it will decrease in order to get 300. This will point we can say where we can get the maximum temperature. And by mathematics beta, we can say we find the value of temperature from PV equal to nRT, PV upon nR. And we know from maxima and minima, if we want to find out the maximum value of temperature, and temperature is the function of volume, we make the straight line relation and Draw a y equal to ms plus c type of line and differentiate them in order to find out the maxima and minima and find the maximum value of temperature. This is done for the mathematics purpose, but in a graphical question we directly say the answer. Okay, here say T1, T2, T3, and we know that if you increase the temperature, the line goes in this direction. Okay, so where the maximum temperature will occur, we can say, sir, here this is the point, here this is the point, here this is the point. We can solve this type of questions also, beta. The next important point, what is the free expansion of gas? Sir, free expansion, there is no opposition. There is no opposition. It means monopoly. Yes, where suppose there is no opposition in front of you, so we can say that if this clamp is open and gas want to expand, so there is nobody present here to resist this expansion. So there is no opposition. It means there is no work. वर्क कब होता है बेटा? जब कोई अपोज करे, कोई अपोज ही नहीं करेगा, काहे का वर्क? Okay, so there is no work in applied force because of work means energy transfer. और वर्क नहीं हुआ, एनर्जी ट्रांसफर नहीं हुआ. We can say कि जब कोई है ही नहीं यहाँ पे, यहाँ कोई है ही नहीं, वैक्यूम है, it means there is no air molecules here. So surrounding तो है ही नहीं. We can say here कि there is no air molecules who can receive the energy. कोई एनर्जी भी नहीं लेगा. We can say कि work transfer zero, heat transfer zero, to change in internal energy zero, to temperature is constant. What is the basic funda of free expansion? What is the basic funda of free expansion? Sir, initial temperature equal to final temperature. Okay, I hope these all points are very, very important. They make a certain region type of question. Okay, beta. So we have to careful about this. This such type of question by involving some mechanics also. If supply a heat to gas by some heater and gas molecules get energized and collide with the wall of piston. So piston move in this direction because they apply a pressure. Because a spring is also connected here, the spring will get compressed. So what is work done by gas? Work done by gas in by two opposition is present here. One is the atmosphere that compress the piston from this side, and another is the spring. So work done by gas, we can say that P into delta P against atmosphere, and this is the work done against the spring, that is the half kx square. I hope this is clear for everyone. Okay, and in order to find out what is the final beta, what is the final temperature, we can use the delta U equal to NCV delta T. And initially piston is here, and if piston is displaced by amount x, then what is the change in volume? A into delta x. Okay, I hope this is clear for you and you can calculate. This is the advanced level type of problem. Okay, if question is very tough in JEE Main, then such type of concept will be asked. Almost in 2013 to 14, such type of question is asked in JEE Main. So once we have to go through with this. We know that cyclic means, sir, we recover back its original position. So it means the change in internal energy is zero because it is a function of temperature. If we reach its initial point, then temperature change is zero. Okay, so heat transfer equal to work transfer. Beta, in this slide, we attach more and more concepts. So what your role, you have to just read every concept, solve each problem which I have attached here. In previous JEE Main some important problem I will also club here. You have to solve this. And whatever doubt you have to ask in WhatsApp group. I hope because of the time constraint, I have to quit the class. And in the tomorrow session, we will start with gravitation. Okay. So I think this session is helpful for you. Thank you so much for attending the session.